Alright guys, this is number 1 on the projectile motion graded problem set. So this problem says a projectile is launched horizontally with a velocity of 25 meters per second from the top of a 75-meter cliff. So the parts are, how many seconds will it take to reach the bottom, how far from the cliff will it land, and what's the impact speed. So the first thing we have to do is set up our idea and our diagram. So there's our cliff, here's our projectile, it's launched horizontally, and it's going to hit the ground. So based on our table of information, we have our x's and we have our y's. On the x side, we're going to have delta x. We're going to have velocity in the x direction and time. On the y side, we're going to have delta y, velocity in the y direction, time. Both of these have an acceleration, but on the x side, it's 0. On the y side, acceleration is gravity, which can be negative 10 for us. Okay, so the first part of the problem, we fill out our information. So our velocity is 25 meters per second. Our y velocity for this one is 0 because it's a horizontally launched projectile. So when it says it's launched horizontally, that's what that means. And then it is the top of a 75-meter high cliff, which is going to be a negative 75 for delta y because it's falling down. So the first thing is how many seconds will it take to reach the bottom of the cliff. Now for horizontally launched projectiles, there's only one time, and it is because it's moving forward and down at the same time that there's only one. So the first thing we want to do for part A, which is to find the time, is to figure out what we know. On the x side, the only information we have is the velocity, so we can't use any x values to figure out what our time is, so we have to look to the y. On the y side, we have delta y and gravity. We're missing time, and we're missing other information, but the v initial y is going to be 0. Okay, like we said, horizontally launched. So that leaves us only with one option, and that's to find time. We can use the free fall equation, which is delta y is equal to 1/2 gt squared. So for our purposes, that's negative 75 is equal to 1/2 g, which is negative 10, and then t squared, which is what we're looking for, t squared. So negative 75 divided by 5, because 1/2 of 10, we get 15 is equal to t squared. So the time it takes is going to be the square root of 15, which is going to be 3.87. So it's going to take 3.87 seconds for this projectile to hit the ground. Now that's going to be 3.87 on both sides of the table. Sorry, that's messy. 3.87 on both sides. Okay, now that we have found the time, the next part is how far from the cliff will the projectile land. That's part B, and that's often called the range. So the range is equal to delta x, so that's how far away. Now we only have one equation for delta x, and that's Vx is equal to delta x divided by t. Now we know the time, and we know the Vx, so all we're left with is the delta x. So you get delta x by itself. It's going to be velocity in the x direction times time. Velocity in the x direction, according to the problem, is 25. The time that we just found is 3.87. So that leaves us with a delta x of 96.75. So that travels 96.75 meters from the base of the cliff. And then finally, our last step is to figure out the impact speed of the projectile. So what happens is that the projectile is going to come in like this. Not exactly like that, but for the most part, like that. And it's going to come down with a velocity that's in the y direction, but it is also going to have a velocity moving this way. That's Vx. Right, now, according to what we know about projectiles, the x velocity is always constant, so v initial x is going to be equal to v final x. So for this problem, our v initial x was 25, so that means that our v final x is also 25. So we have found one part of it. So now we're left with trying to find vy, and we need to find vy in order to find the final v total, which is what happens. So to get v final in the y direction, we have to look at just the y direction itself. Now, it starts from rest. It starts at an initial velocity of 0, it falls for about 3.87 seconds, and it accelerates at a rate of 10 meters per second per second. So what that means, according to this equation, v final is equal to v initial plus acceleration times time is that however much time it takes multiplied by gravity is going to give us the final velocity. So negative 10 times 3.87 plus 0 is going to give us negative 38.7 meters per second. Negative because it's falling down. So now what we have is a triangle, just like the image that I have up top here, except we're going to have the x of 25, the y of 38.7, not drawn to scale, and then the final total velocity here of the dotted line hypotenuse, which we then need to figure out using the Pythagorean theorem. And for us, the v final total is going to be equal to the square root of v final x squared plus v final y squared. So that's going to be the square root of 25 squared plus 38.7 squared. And I dropped the negative because when you type it into your calculator, it's not going to square it as a negative number. It's going to square it first, and then it's going to use the negative, which is going to throw it off. So you can just drop it. You don't have to worry about including it. So when we actually go through 25 squared plus 38.7 squared, and then we take the square root, we're going to get the square root of 2,122.69, which gets us a total final velocity of 46.07 meters per second. So according to our problem, can I zoom out? No, I cannot. All right. So we have a time of 3.87 seconds, a range of 96.75, and a total final velocity of 46.07 meters per second.